Howdy y'all, and welcome to this special hurricane outlook for this year. To take a look at what we could expect for hurricane season, we'll have to take a look at our ENSO pattern. What is ENSO? It's El Nino Southern Oscillation, determines whether or not we're going to be in El Nino, La Nina, or ENSO-neutral. Now what does that even mean? Well, in simple terms, basically we look down here in the tropical Pacific near the equator, in the key ENSO monitoring regions, what it's called. El Nino is warmer waters, La Nina is colder waters, and ENSO-neutral is basically the Goldilocks. It's neither too hot or too cold. And you can see here, this is for April. We'll take a look at May here in a little bit. We see we have a little bit of both here, which basically means we're in ENSO neutral. And in simpler terms, during El Nino, think of it like this, where we have a fat guy and a skinny girl on a seesaw, where the fat guy is just sitting on the seesaw and the skinny girl doesn't have a chance. RFK Jr. would be yelling at this fat guy like Sergeant Emery yelling at Private Pile to tell him that he has a jelly donut and is giving him a lecture on the jelly donut. And basically, El Nino is above average here in the central and eastern Pacific, while the Atlantic and Gulf remains pretty quiet in most cases. Now during La Nina, which we were in last year, it's just the opposite of that. We have an above average hurricane season out here in the Atlantic and Gulf, and it's a little bit quiet in the central and eastern Pacific. I'll explain why that is here in a little bit, but you can see the fat chick on the right holding down the seesaw while the skinny guy on the left is crying his eyes out because he can't have fun on the seesaw because this fat lady just can't lay off the cheeseburgers or the brownies or the cupcakes because she just wants to sit there. Shame on that lady. But during ENSO neutral, which will be in this year, basically means we're going to be dealing with an average season, kind of an unpredictable, uncertain kind of season, because we could still have La Nina or El Nino influence. So we're going to cover the Atlantic first, which starts on June 1st all the way into November 30th. It peaks in mid-September into October. Remember back to Helene and Milton, we had those in September and October, and even Beryl, I think that was beginning of September, but major hurricanes typically occur in September and October. Now to go more in depth with ENSO neutral, we're going to take a look at the Climate Prediction Center's ENSO page, which was updated May 19th, but the bar graph I'll show you here in a little bit was only updated May 8th, and I think they only update that once a month. And we can see the map here that we are in ENSO neutral, have warm and cold, so basically we have a little bit of both going on. And as we take a look at the bar graph here, there's a greater than 50% chance of ENSO neutral persisting through August through October, which is peak hurricane season. And you can see that we are definitely in a strong ENSO neutral influence all the way out into June, July, and August, and could come into a weak La Nina as we head into peak hurricane season and even into the fall and winter months. But of course, we're not going to talk about the fall and winter months in this video. I'll save that for those outlooks, so subscribe so you don't miss those outlooks, by the way. Now the Atlantic has more information than the Eastern and Central Pacific for some reason, but I still created a presentation for y'all, so we'll get into that here in a little bit. Now NOAA issued their outlook a couple days ago, May 22nd. You can see 60% chance of being above normal, 30% chance near normal, and right around a 10% chance of below normal. And I'll explain why here in a little bit. But expect 13 to 19 named storms, 6 to 10 of them being hurricanes, and 3 to 5 of them being major hurricanes. The Colorado State University, they issued their outlook in March. They're expecting 17 named storms, 9 hurricanes, and 4 of them being Cat 3+. AccuWeather sort of goes along with the Weather Channel and all those guys, but they're expecting 13 to 18 named storms, 7 to 10 of them being hurricanes, 3 to 5 of them being major, with 3 to 6 of them causing direct impacts. Now last year was a weak La Nina year, and we could come in on weak La Nina as we head into the peak months, but Canada will change obviously. But we had 18 named storms last year, we had 11 hurricanes, 5 major, with 6 of them causing direct impacts. There was Beryl, Milton, and Helene. And on average, we typically see 14 named, 7 being hurricanes, 3 major, and 4 on average hitting the U.S. And here are the names of the Atlantic tropical cyclones, and here are the supplemental names. We rarely use these, but just in case we come in on an above average season where we run out of names, here are the supplemental names. Now, before we get into the rundown summary of the Atlantic, we're going to take a look at the sea surface temperatures all the way into the beginning of June. And it's looking like as we head into the beginning of hurricane season, it's looking like the sea surface temperatures are really going to heat up out there. Think back to Milton, for example, on October 9th. we had over 90-degree sea surface temperatures down here in the Gulf, and we had a little disturbance down here, interacted with that environment, and it intensified rapidly. Within 12 hours, it became a Category 5, but of course weakened down right before it made landfall, luckily, as wind shear tore it apart. And as y'all know, wind shear tears hurricanes apart because hurricanes do not like wind shear. But as we can see, expect some pretty prime conditions out there in the Atlantic for the start of hurricane season. And what we'll use to track hurricanes this year, at least future potential hurricanes. Now keep in mind, anything over 100 hours out is pretty much impossible to forecast, especially hurricanes, but we'll typically use this and I'll tell y'all whether or not the hurricane will actually form or not. But expect an above average monsoon season in Western Africa, which causes a lot of tropical cyclones and tropical depressions and stuff out here, which the National Hurricane Center will issue advisories ahead of time. You see something like this, if it's more north, interacts with a favorable environment, it can do the spinny-roo and come out here, or it can recurve. But that will die off, of course, and it's not looking like any hurricanes, tropical storms, or nothing is going to be in store out there, luckily. So that's some good news. But of course, as we take a look at the National Hurricane Center, there is nothing within the next 7 days, so that is some good news, y'all. Hurricane season starts on June 1st, so start off hurricane season, looks like nothing out there. But it's the same thing with last year as well. There was nothing out there, it was quiet, and everybody thought, oh, all the weather people are wrong, but it only takes one big hurricane to cause a significant hurricane season, so keep that in mind. Now, what we've learned thus far is that basically hurricane season starts June 1st all the way into November 30th, and research suggests that an above average season is favored because of warm sea surface temperatures are going to be expected. They're going to be above normal in the Gulf, America, down by the Caribbean, and even the main development region, the Atlantic basically. Though the waters are going to be a little bit cooler than last year's, but still fueling storm energy. ENSO-neutral conditions are favored at 74% through summertime, with a potential weak La Nina by fall. And I did mention that we could be having a weak La Nina, which is going to be reducing wind shear, which means more hurricanes. Hurricanes hate wind shear. And West African monsoons are going to be potentially active, increasing tropical waves that spawn hurricanes. I did mention that earlier as well. And current status, there's of course no hurricanes out there, tropical storms. Pretty typical for this time of year, but we have had hurricanes in late May before. And historical averages from 1991 to 2020, there's been 14.4 named storms on average, about 7.2 hurricanes, 3.2 major hurricanes. There's a record amount of named storms, right around 30 in 2020, 7 named storms in 2015, for example. So there's the Atlantic. Basically, the Atlantic is going to be expecting an above average hurricane season, so prepare, y'all. And we'll get into how you can prepare here in a little bit, but let's go ahead and get into the Pacific. Now, I did say there's not much information on the Pacific, so I put it into this presentation here. I know it's a little bit cut off, sorry about that, but best I could do, y'all. Now, this hurricane season indicates a below normal season, 50% chance of being below normal. And there's a 30% chance of a near normal and a 20% chance of an above normal season. Now, the Eastern Pacific hurricane region covers the eastern North Pacific Ocean, east of the 140° west and north of the equator. And here is a map of this, by the way. Here's the Eastern Pacific, here's the Western and Central Pacific. Hawaii is right here. So if a hurricane out here, just like last year, I forget the name of it, but we had a hurricane out here and I called it something. And of course, this lady said that it's actually a Central Pacific named storm, and I didn't know that, so thanks to that lady, weather woman, she's very good. But when it crosses this boundary just east of Hawaii, then it becomes a Central and Western Pacific Ocean hurricane. So the outlook this year calls for a 70% chance of each of the following ranges of activity. Right around 12 to 18 named storms is expected in the Eastern Pacific, 5 to 10 hurricanes, and 2 to 5 of them being major. Now don't worry about the ACE, that's all just complicated jargon that they use. Don't worry about that, y'all. Now here are the names of the Eastern North Pacific. These names are recycled every 6 years, so the next time you'll see this one will be in 2031. Now the Central Pacific, they're expecting a very below average season with over a 30% chance of that, and right around a 50% chance of being near normal and a 20% chance of being above average, but a chance nonetheless. In terms of storm numbers, the forecast calls for right around 1 to 4 tropical cyclones across the Central Pacific, which is located north of the equator, just like I showed y'all earlier, between the 140° west and the international date line, basically just east of Hawaii, basically. A near normal season has 4 or 5 tropical cyclones. Tropical cyclones include tropical depressions and tropical storms, and obviously hurricanes. And as you can see, this is all the information I could find on the Central Pacific. I don't know why they don't have much information, because there's still people out in Hawaii, but that's the only information I could find, y'all, so basically expect a below normal season, but prepare for an above average season. Like I say all the time, prepare for the worst and hope for the best. Now here are the Central North Pacific names. Now these names are hardly ever changed out unless there's a catastrophic hurricane. There are the names of the Central Pacific. Let's go ahead and take a look at the Pacific. Now we're going to go wide view with this. Keep in mind that right here is the cutoff line between Central and Eastern Pacific, and we can see that the sea surface temperatures out there can be relatively cool up here, and I know there is a little tropical depression down here just west of Mexico. Not expecting it to turn into much, so nothing to worry about here in Hawaii. It's looking like not really much favorable conditions for hurricanes as we head into hurricane season. Hurricane season has started in the Eastern Pacific on May 15th, so I wouldn't expect much in the way of strong hurricanes in the Pacific region, east and central, but you never know. Can and still will change, but prepare for the worst, hope for the best, obviously. And as we take a look at the infrared radar here, see there is a tropical depression just west of Mexico, and could be coming on some showers here in Hawaii, but really I'm not expecting much in the way of any sort of cyclones or tropical storms or any of that nonsense as we head into the beginning of hurricane season. So hopefully I'm making sense to y'all, but basically what we've learned thus far about the Pacific hurricane season is basically Eastern Pacific starts on May 15th to November 30th. The Central Pacific starts on June 1st, the same as the Atlantic. And it seems likely that activity will be near to below normal, influenced by suppressive conditions, just like I showed you earlier, that could be coming in on some pretty cool sea surface temperatures out there in the Eastern Pacific, and could be coming in on a lot of wind shear. Not much in the way of hurricane activity, but again, prepare for the worst, hope for the best. In the Eastern Pacific, per NOAA, they're calling for 12 to 18 named storms, which averages right around 15. 5 to 10 hurricanes, the average for that is 8. 2 to 5 being major, with a 50% chance of below normal activity, 30% chance of near normal, and 20% chance of above normal. Now in the Central Pacific, per NOAA on May 14th, that's when they issued their update, they're expecting 1 to 4 tropical cyclones. They come in on right around 4 to 5 on average, with 30% chance of being below normal, 50% chance near normal, and 20% chance of being above normal. So basically, Eastern Pacific, Central Pacific, expect below normal hurricane season is what I'm saying. The key drivers of this hurricane season and why it's going to be below normal: cooler sea surface temperatures. It's going to be limiting storm activity just west of the 100° west line. Negative Pacific oscillation, the PDO, linked to cooler waters basically. High wind shear. Hurricanes hate wind shear, which suppresses development. ENSO-neutral 63% chance through peak months, like September for example. It's going to be 25% chance of a weak La Nina during the fall months. It's going to be reducing activity. And obviously there's no hurricanes or anything like that. There is a tropical depression just west of Mexico, but not really too worried about it. Now, historical averages in the Eastern Pacific, there's 15 named storms on average, 8 hurricanes and 4 major. Central Pacific, you all see 4 to 5 tropical cyclones, with a record amount of 27 named storms in 1992 and 8 named storms in 2010. So now that we know all that, we are going to be in an ENSO-neutral season, but it's looking like it's going to be more of a La Nina kind of year, and we're expected to be in a weak La Nina as we head into the fall months, think like September, August, that time frame. So what I would expect is basically this. This is what I would expect for this year's hurricane season, although we're going to be in an average season, which means a lot of uncertainty in the Atlantic and Pacific. So it takes one hurricane to make it a bad hurricane season. So keep that in mind, prepare for the worst, and hope for the best. And how you can prepare is, before hurricane season, develop an evacuation plan, assemble disaster supplies, get an insurance checkup, of course. Insurance is high in the coastal region. Create a communication plan with handwritten list of contacts and strengthen your home. And know your risks, of course. Consider if you're in a storm surge area or flood zone. Determine if you live in a flood prone area. Find out if you live in an evacuation zone. Identify your home structure risk. Mobile home, basement can be vulnerable. And Here are some risks when it comes to hurricanes, storm surge, and winds, and inland flooding. Tornadoes are common on the northeast side of hurricanes, and rip currents and rough seas are common both before and even after a hurricane, making swimming and surfing very dangerous. Now, you gotta understand forecast information. Don't rely on me, don't rely on really anybody except for the experts at the National Hurricane Center and your trusted local meteorologist. Go rely on those guys. Don't just rely on me, Ryan, or any other YouTuber. Please rely on those guys. If you want to see on the ground coverage, of course, we got storm chasers on the ground as well. We've got Vince, Brandon, Corey, and a whole bunch of others. Go check those guys out if you want to know what the conditions are for your area, but basically just rely on the experts, essentially. And of course, if you're on social media, don't trust what you see. I'll be posting a lot on this. If a hurricane is coming, you'll typically see the worst case scenario, a 945 low, end of the world kind of hurricane. But this is typically what happens right here in the bottom right. But in most cases, we typically get a lot of these, just like during Milton and Helene. So beware of fake forecasts. And of course, there's going to be plenty of fish storms is what I'm expecting this year, which is a lot of them are going to recurve. So when there is a hurricane, get moving. Protect your home, cover windows, secure doors, and loose items. Of course, y'all should know this if you are a native to Florida and Texas and the Gulf Coast. Ready your go bag, medicine, supplies. Also make sure you pack that up. Help your neighbor, especially the elderly and other vulnerable people. Don't be scumbags. And follow evacuation orders if given. And stay protected during the storm. If you're staying behind, stay in your safe place from water and wind. Make sure you're in a higher area. Protect yourself. Like a parking garage would be a pretty good place. I know some storm chasers that hide out there when there's a bad hurricane. And have a way to get weather alerts and forecast updates via phone or weather radio. Keep in mind that impacts can be felt far from the coast, just like Helene up in the Appalachian Mountains. It's pretty rare to see that, but you can still see that. And listen to local officials and avoid travel unless ordered to evacuate. And of course, if you're heading back to your home, make sure that you only do so when it's safe to do so. Remain vigilant as hazards remain, like heat or downed power lines, floodwaters, and even more than that. Clean up safely, don't push yourself, and check on neighbors. Only use generators outdoors, obviously 20 feet from your home. And prepare for the likelihood that help and communications may not be available. So take action today, y'all. Determine your risks from water and wind. Know if you're in a hurricane zone, basically. Begin preparing now before a storm. Learn how to understand hurricane forecasts and alerts. Basically, go follow your trusted local meteorologist, download a weather app, and go to the National Hurricane Center for more information on hurricane season. And learn what to do before, during, and even after a storm hits. And here are the causes of direct fatalities from hurricanes and tropical cyclones. Note that 88% of deaths can be attributed to water hazards. You can see storm surge is 50% of the deaths when it comes to hurricanes. Tornadoes are typically on the northeast side of hurricanes. That's only 3% of the deaths from them. Wind is only 8%. And rain is only 27% of the deaths, basically flooding, essentially is what that is. Now the formation of a hurricane, if y'all are interested in this, basically warm moist air rises into the atmosphere, cools, water vapor condenses, and clouds form. More air rises, creates an area of low pressure over the ocean. As air continues to rise, a tropical depression forms. Tropical depressions bring thunderstorms with winds between 37 and 62 kilometers per hour, or basically right around 80 mile an hour essentially. Air continues to rise if it continues to strengthen. Rotating counterclockwise, the storm builds to a tropical storm with winds in excess of right around, I would say, 70 to 80 mile an hour. It produces strong thunderstorms. If it continues from there, goes into step 4, when winds exceed 119 kilometers per hour, or basically over 100 mile an hour essentially. The storm becomes a hurricane. Only 1% of tropical storms become hurricanes. So that's a pretty interesting stat. And below here you can see the eye wall, and the rain bands. And on the northeast side of hurricanes, basically the front right, that's where you see the maximum impact, and that's where tornadoes occur at, is on the upper right side of the hurricane. The back left of the hurricane is the weakest side, the back right is where you get all the wind, and the front left brings all the storm surge. So, for example, if Miami gets hit by a hurricane, they get a lot of storm surge because this side of the hurricane pushes all that water inland. And we did come in on this last year with Milton, the eye wall replacement cycle. Basically, the hurricane gets so strong that it replaces the eye wall, it becomes small basically, and then a new eye wall forms, and then once it's completed, a new eye wall forms, and the hurricane can become either stronger or weaker, it just depends. So when you see the eye wall replacement cycle or you hear that mentioned, basically this is what that means. Now with all that known, let's go ahead and get into some historical ENSO-neutral hurricanes. Since we are going to be an ENSO-neutral this year, neutral ENSO years lack strong El Nino or La Nina influence, leading to variable hurricane activity influenced by other factors like Atlantic sea surface temperatures, for example. Starting off with the 1900s, keep in mind, not much documentation back then, but on September 8th of 1900, we had the Galveston hurricane, which was a Category 4 with 145 mile an hour winds, which drowned Galveston, Texas in a 15-foot surge, killed over 6,000 to 12,000 people. The deadliest U.S. hurricane on record. Clara Barton rode through floodwaters catching her baby, but thousands perished. The city rebuilt with a seawall raising its elevation. The next one, in 1938, we had the New England hurricane on September 21st, which saw the Long Island Express, as it was called. It was a Category 3 hurricane with 120 mile an hour winds, slammed Long Island at 70 mile an hour. A 17-foot surge flooded Providence, where a school teacher saved students from rising waters, killing 682 and causing $306 million in damage in 1938. This neutral year shock pushed forecasting advances. Next, we have the 1954 hurricane, which was Hazel on October 15th. Hurricane Hazel, which was a Cat 4 with over 130 mile an hour sustained winds, hit the Carolinas with a 18-foot storm surge, which wiped out Myrtle Beach. A Wilmington family survived in their attic. Hazel's remnants dumped 34 inches in Ontario, which killed over 81, with 95 U.S. deaths and over almost $300 million in damage in 1954 dollars. In 1969, we had Hurricane Camille. On August 17th, it brought Hurricane Camille, a Cat 5 with 175 mile an hour sustained winds, to Mississippi. A 24-foot surge leveled Pass Christian, and a Gulfport family clung to their roof. Virginia flash floods killed 113 with 259 deaths and over $1 billion in damage in 1969 dollars. And we can see the explanation of Hurricane Camille. One of 4 Category 5 hurricanes to ever strike the continental U.S. Recap of the 1900s. We had a lot of ENSO-neutral years in the 1900s. And how this could resemble this year is basically warm sea surface temperatures may drive strong Gulf storms like Camille, or northern surprises like in 1938. Hazel's inland flooding could repeat in the Carolinas, but this year's better forecasting and warnings reduce deaths compared to the 1900s. Now moving on to the early 2000s, there was only the 2003 Hurricane Isabel. On September 18th, Hurricane Isabel, a Cat 2, with 105 mile an hour winds, struck North Carolina's Outer Banks. Its sprawl flooded Virginia, trapping a family for days. Power outages hit millions, with 51 deaths and over $5.5 billion in damage in 2003. And this was the only neutral year hurricane on record. Basically, this year could resemble Isabel's broad flooding, with low shear supporting large storms across the mid-Atlantic or the Carolinas, though modern radar cuts down on the risks. Now, the mid-2000s from 2005 to 2009, we had a hyperactive season in 2005 with Hurricane Katrina. Everybody knows this one. On August 29th, Hurricane Katrina, a Cat 3 when it made landfall, it was a Cat 5 at one time, had winds of 125 mile an hour sustained winds, flooded New Orleans, and the levee breached, where a mother waved for rescue from her attic as water rose, with 1,800 deaths and $125 billion in damage. And we can see an explanation of Katrina right here. Katrina was located approximately 73 nautical miles of that certain buoy, and that buoy reported seas of 12 plus feet for 47 consecutive hours. The highest seas reported on August 29th were at 55 feet, so it was one of the deadliest hurricanes on record. The next deadliest one, which was Helene, which we'll get into that one here in a little bit, which pretty much everybody knows about that one. The next major hurricane in 2005 was Hurricane Rita. On September 24th, a Category 3 hurricane with 115 mile an hour winds hit Texas and Louisiana. A 15-foot surge erased Holly Beach, and a Houston evacuation bus fire killed 23 elderly, with 120 deaths and $18.5 billion in 2005 U.S. dollars. The next big hurricane in 2005 was Hurricane Wilma. On October 24th, it was a Category 3 hurricane with 120 mile an hour winds, struck Florida. Its record low of 882 millibars fueled winds that shredded Naples. A family hid in their bathroom as their roof caved, 35 deaths and $20.6 billion of damage was reported. To recap, it was a hyperactive year in 2005. The neutral season brought multiple major hurricanes because of warm sea surface temperatures and low wind shear. And how it could resemble this year is basically, we have those conditions going on this year actually, in the Atlantic anyway. Now, most recent hurricanes from 2010 to last year actually, we had Hurricane Harvey in 2017 on August 25th. It was a Category 4 with 130 mile an hour winds. It hit Rockport, Texas, and then stalled out, dumping over 60 inches of rain over Houston. A family waded through floods to safety with 107 deaths and billions of dollars in damage. Next one is Irma on September 10th of 2017. It was a Category 4 hurricane with 130 mile an hour winds, struck the Florida Keys with 180 mile an hour peak winds, which destroyed Bermuda's homes. A Key West resident sheltered in a school as winds roared with 134 deaths and $77.2 billion in damage. And Maria, back in 2017 on September 20th, it was a Category 5 with 175 mile an hour winds. It's devastated Puerto Rico. A San Juan family went weeks without water amid months-long outages. Nearly 3,000 died with over $91.6 billion in damage. 2019, we had Hurricane Dorian, so we had a lot of ENSO-neutral hurricanes from 2010 to last year, actually. On September 1st, 2019, with over 185 mile an hour sustained winds, stalled over the Bahamas, flattening Grand Bahama. A resident clung to debris as homes vanished, with 74 deaths and $3.4 billion in damage. Now, most recently, we had Helene. We all know this one on September 26th. Hurricane Helene struck as a Category 4 with 140 mile an hour sustained winds, slammed Florida's Big Bend, unleashing a 15-foot surge and catastrophic inland flooding in Asheville, North Carolina. A family fled as the Swanoa River swallowed homes, with 95 deaths tied to freshwater floods, killing 250 and causing $80 to $100 billion in damage. Helene's neutral year inland wrath, the deadliest U.S. hurricane since Katrina, and they're still picking up the pieces down there. I know when that hurricane struck, the government didn't take care of y'all down there, unfortunately, until at least Trump got in there. It wasn't a political issue. It was just that administration was very incompetent and didn't care about y'all down there. And now they're finally picking up the pieces down there, which is very good. Milton, on October 9th of last year, it was a Category 3, weakened down significantly from a Cat 5, with 120 mile an hour sustained winds hit Siesta Key in Florida just weeks after Helene. Its rapid intensification to Cat 5 with 180 mile an hour sustained winds in 12 hours, fueled by Gulf sea surface temperatures near 90 degrees at the time, spawned 40 tornadoes, including an EF3 in Fort Pierce. A Tampa family evacuated as 10-foot surges flooded streets, with 21 deaths and $20 to $50 billion in damage. So we can see that last year we had very, very hot sea surface temperatures, and it fueled this storm within 12 hours, becoming a major hurricane. And we could come in on that this year as well. Here is some footage of it weakening out right there as it came into some wind shear. And then it hit inland and caused a lot of tornadoes and a lot of damage. And here is some more footage up here on the top right of some storm surge. So to recap, neutral years produced intense storms with better forecasting but high economic costs. And we can see from 2017 all the way into last year of how this year could resemble rapid intensification. Milton's 180 mile an hour peak winds and heavy rainfall from Helene and Harvey are likely this year, with warm Gulf and low shear conditions. Florida, the Caribbean, and inland areas face surge, flood, and tornado risks, just like in last year. Now, hurricanes' impact on wars. Now, keep in mind, Revolutionary War, there wasn't any records back then, honestly, but this is the best I could find. Now, the Revolutionary War involved significant naval activity, particularly in the Caribbean, where Britain and France competed for control of colonies and trade routes. Hurricanes posed a major risk to wooden sailing ships and coastal fortifications with little ability to predict or mitigate their impact due to the lack of modern meteorology. Now, some key events during the Revolutionary War hurricane season. The Great Hurricane of October 1780, one of the deadliest Atlantic storms on record, struck the Lesser Antilles during the war's later stages. It devastated a British squadron under Admiral Sir Peter Parker, anchored at St. Lucia, sinking or damaging numerous ships and killing hundreds of sailors. This storm also ravaged Barbados and Martinique, disrupting British naval operations and supply lines in the region. While it didn't directly alter specific battle outcomes, that loss of ships likely weakened British's ability to reinforce or resupply forces in the West Indies, potentially aiding French and American efforts, indirectly by stretching British resources thin. Now, other storms during this period, such as those in 1776 and 1782, are less documented, but likely caused similar disruptions to shipping and coastal defenses, particularly in the southern colonies like Georgia and the Carolinas. Commanders probably adjusted patrol schedules and avoided major naval movements during peak hurricane months, August through October, relying on seasonal patterns to minimize losses. Now, the War of 1812. This conflict saw naval engagements along the U.S. coast and Gulf of America, where hurricanes could disrupt British and American operations. A September 1812 hurricane hit Louisiana, potentially affecting New Orleans, a key supply port. Though specific military impacts are unclear due to limited records, such storms likely delayed troop movements or trade shipments, complicating logistics for both sides. Now, the Mexican-American War, 1846 to 1848, a hurricane in October of 1846 struck Texas, a staging area for U.S. forces invading Mexico. It may have delayed shipments of supplies or reinforcements to General Zachary Taylor's army, though documentation is sparse. The storm's timing suggests minor logistical setbacks rather than major strategic shifts. Now, the Civil War, one of the biggest wars, other than the Civil War. The Civil War's extensive coastal and naval operations made it particularly vulnerable to hurricanes. A standout example is Hurricane Santa Ana, which hit Key West on October 3rd to 4th of 1864. Key West was a vital Union naval base for blockading Confederate ports and supporting Gulf Coast operations. The storm damaged ships, docks, and infrastructure, likely disrupting blockade efforts and delaying supply missions to Union forces in the region. Another potential impact came in September of 1862, where a hurricane affected New York and New England. While it dissipated before the Battle of Antietam, September 17th, its rainfall may have softened ground conditions, indirectly influencing troop movements. Overall, hurricanes forced the Union Navy to pause or reroute operations, while Confederate forces, reliant on blockade runners, faced added challenges during storm seasons. Now, World War I, 1914 to 1918. U.S. involvement began in 1917, with the war focused on transatlantic troop and supply shipments to Europe. Atlantic hurricanes posed risks to convoys crossing from East Coast ports like New York and Newport News. A tropical storm in September of 1917 hit New England, potentially delaying shipments of troops and material to the European front. While not a major hurricane, its timing during peak convoy activity suggests minor disruptions to the flow of reinforcements. Specific losses or delays are not well documented, obviously, reflecting the war's primary focus on Europe, where Atlantic storms had less direct impact. The hurricane season likely influenced convoy scheduling, with planners avoiding peak storm periods when possible. However, the relatively short U.S. involvement and the European theater's distance from hurricane-prone areas limited the season's overall effect compared to later conflicts. And that actually gave me an idea to actually cover hurricane season for next year for Europe. So stay tuned, y'all. Now, World War II, one of the next biggest wars, from 1939 to 1945. World War II relied heavily on Atlantic shipping lanes for the Battle of the Atlantic, where Allied convoys supplied Europe against German U-boat threats. U.S. coastal bases and Gulf ports were critical for both Atlantic and Pacific, making hurricanes a significant logistical concern. Hurricane Deanna, August to September of 1944. This storm struck the East Coast ports during preparations for European operations like Operation Market Garden. It damaged infrastructure and disrupted shipping schedules, delaying troop and supply movements across the Atlantic. Hurricane King, October to November of 1944. We can't have hurricanes in November, y'all. It affected the Gulf Coast ports. This hurricane complicated logistics for the Pacific, where supplies were routed, though the Gulf to the Panama Canal damaged docks and rerouted ships, likely slowed the flow of resources. We had Hurricane Pam in July of 1943, a unique case where a storm off the Azores sank two German U-boats, inadvertently aiding Allied efforts by reducing submarine threats to convoys. Now, multiple hurricanes each year, for example 10 named storms in 1944 alone, disrupted shipping lanes, damaged coastal bases, and forced U.S. Navy to adjust convoy routes and schedules. For instance, bases in Florida and the Carolinas faced repeated storm threats, impacting training and deployment timelines. While no single storm halted a major campaign, their cumulative effort strained logistics, especially during critical operations like the build-up to D-Day, June of 1944, which was wisely scheduled outside peak season. Naval planners used emerging weather forecasting to mitigate risks, a significant improvement over earlier wars, which, speaking of D-Day, if they went a little later to attack the Germans, then they would have been wiped out by a major storm. They would have had to have pushed that back even further, so they went at a perfect time. Strategic and planning considerations. Across these conflicts, hurricane seasons shaped military strategies, particularly for naval and coastal operations. Leaders often scheduled major campaigns like the amphibious landings outside peak hurricane months to avoid disruptions. D-Day's June timing in 1944 exemplifies this, though earlier wars relied more on historical patterns than forecasts. Now, some logistical vulnerability. Storms damaged ships, ports, and supply lines, forcing delays or rerouting. This was most pronounced in the Civil War and even in World War II, where sea-based logistics were critical. Now, pre-meteorological challenges before the 20th century, reliance on seasonal knowledge, avoiding August to October in the Caribbean was common, as seen in the Revolutionary War, naval adjustments post-1780. So, really, they had to rely on instinct back in the Revolutionary War time because there wasn't radar, obviously, and there wasn't many meteorologists back then. They just relied on their mindset of basically during set periods of the year, there was hurricane season. Now, some comparative analysis before we get into the conclusion here. Coastal versus inland. Coastal wars like the Civil War and World War II saw greater hurricane impacts due to reliance on ports and navies, while inland campaigns like the Revolutionary War's northern battles were less affected, though remnants could bring rain. World War II benefited the most from basic weather forecasting, and we even took out a weather station in Germany back in World War II, which helped us out significantly. Reduced surprises compared to earlier wars, like the Revolutionary War, where storms struck unpredictably because we didn't have radar. We didn't really care about the weather too much back in the Revolutionary War time because we were too busy trying to fight off Britain because they wanted to tax us to death and we wanted to break away, and we just relied on instinct back then pretty much. And the severity of this, the Great Hurricane of 1780 and the World War II's frequent storms stand out for their scale, while Civil War impacts were more localized but still operationally significant. In conclusion, hurricane seasons influenced wars from the Revolutionary War to World War II by damaging fleets, disrupting supply lines, and prompting strategic adjustments. Key examples include the Great Hurricane of 1780, which weakened British naval power. Hurricane Santa Ana hampered Union operations in 1864, and even World War II's multiple storms delayed Atlantic convoys. While rarely decisive for battle outcomes, their logistical and planning impacts were substantial, especially in hurricane-prone regions, highlighting nature's role in shaping military history. So hopefully y'all enjoyed that little history segment there. That's a lot of stuff I actually did not know about. So, to conclude here, I know I made this video a little long for y'all, and hopefully y'all got a lot out of it. It's a lot of information there, but in summary, basically, the Atlantic hurricane season is going to be active this year, potentially, while the Pacific Ocean, the Eastern and Central Pacific, is going to be a little bit quieter than normal, but keep in mind, it takes one significant hurricane to count as a big hurricane season, so keep that in mind, y'all. Because just like in 1969 when we had Hurricane Camille, and back in 1780 during the Revolutionary War, those were some big hurricanes in those years, and those count as big hurricane seasons, and this year could resemble 2005, but like I always say, even though if the hurricane season's quiet, prepare for the worst, but hope for the best. So basically, monitor updates at the National Hurricane Center, follow your local news stations for local updates, download some weather apps, be aware of fake news on social media, don't buy into fake forecasts, don't buy into clickbait, you can rely on me, you can rely on Ryan, you can rely on Ponder, Max Velocity, all of those guys are good. I will make sure that I won't clickbait y'all or lead y'all in the wrong direction. I don't do that here. And you can also follow some storm chasers. They'll actually be on the ground this year down there in Florida and the Gulf Coast, or really anywhere hurricanes are here in the United States. If you want to know what's going on at your home, they'll be on the ground. So follow Vince, Brandon, Corey, and other storm chasers. They're all good. So hopefully y'all enjoyed today's video. I know it was a long one, a lot of information, but again, hopefully y'all like, comment, and subscribe. Share the video so more folks are informed about the weather. So here on Is Weather, we try to make weather forecasting fun and informative. So again, thank y'all for watching. Prepare for the worst, hope for the best this hurricane season, and until next time, never stop forecasting.